Okay, we're going to pick up here today. Yesterday, we just briefly started the notes here for Chapter 4. Chapter 4 is focusing on different ways to properly gather a sample. And the key component of that so far that we have discussed is we always want to make sure that we are gathering a sample in a random fashion. One of the things we touched on just at the very end of yesterday's video was this idea of bias. Bias is referring to the method that you're using to gather your data. That method is going to result in your data either consistently overestimating the thing that you're trying to calculate, or it is consistently underestimating the thing that you're trying to calculate. I think yesterday the example we used was standing in the junk food aisle of the grocery store and then surveying like every fifth person what their views were on whether they supported a healthy lifestyle or not. Okay, it is very likely that the people that you would encounter in the junk food aisle may not support a healthy lifestyle as much as truly a random person that you would have selected. Okay, so that would be underestimating the true proportion of people who probably support a healthy lifestyle. Okay, we're going to come back and touch on this AP exam tip in just a moment, but I just want to discuss here today with you two bad ways of selecting a sample. And we're going to start with a convenience sample, and it is just as it sounds. A convenience sample is when the researcher is simply choosing the people for his sample because they happen to be easy to reach. For example, let's say that we want to find out how long students at our school spend doing homework last week, okay? And so we go to the school library and we ask the first 30 students that we see about their homework time. Okay, we want to think about maybe what would be a problem with conveniently just going to the library and asking students there about how long they're spending on homework. Okay, maybe an issue with this is it's possible that the students in the library are working on big projects that require a lot of time. Maybe they're in the middle of working on a big project for a class, and so in the last week they would have spent a large amount of time working on homework and projects, and so if that's the case, that would overestimate the average time that students in general are spending on homework for that reason. Now, this is just one possibility. The thing that you're going to find in AP Stats is as long as you can come up with a good reason and support that reason, there's lots of different answers. Someone might be thinking, well, look, someone who's going to go to the library maybe after school and work on their homework might be someone that's a little bit more studious than a person who feels like I'm just going to leave it in my locker and I'm not going to do that homework. And so you're going to, it still possibly would be overestimating the average time spent on homework because of the location that you're going to select your sample could be filled with people that are more inclined to spend more time on their homework or be more studious in that way, okay? So this convenience samples tend to lead to bias because they're not truly a random process, okay? Another bad sample technique here is what is called voluntary response sample. Okay, a voluntary response sample, it's described here as consisting of people who choose themselves by responding to some general invitation. For example, maybe this is people who are deciding to join, or maybe they're allowed to respond more than once. You get this a lot with, there's different shows online like American Idol and things where people can call in and like cast their vote. People who don't care are not going to volunteer to respond. Okay, so sometimes the results of the survey, they weren't truly random because only the people interested in giving their opinion are the ones who participated in the sample, okay? So here it says this attracts people who feel strongly about an issue or who often share maybe the same opinions. And so you're kind of, again, getting that bias action in there where, if it's all attracting the same people with the same opinions, it's either over or underestimating the variable that you're trying to measure. Here's an example. Lou Dobbs, he has a radio show. He is a radio show host, and he was against offering illegal immigrants driver's licenses. Okay, so during his show, he invited his viewers to go to his website and vote on the following question. Okay, and the question was this: would you be more or less likely to vote for a presidential candidate who supports giving driver's licenses to illegal aliens? Okay, now here's what his results were. Okay, the results were 97% of the 7,350 people who participated voted that they were less likely to vote for a presidential candidate with those views. Okay, now here's the problem with this essentially voluntary response sample. Okay, people chose to respond, and they were already viewers of his program. Okay, so they were already a subset of, say, the population of the United States, because they were already watching or listening to the Lou Dobbs show. So if they're listening to him, it's very likely that they have similar views as he does. So if we're saying 97% of all of the people who participated in this said they were less likely to vote for a presidential candidate who had this view, then it's likely that those results are overestimating the true proportion of those who are less likely to vote for the presidential candidate who have those views. Okay, it would be a massive overestimation because we just have a large chunk of people who all typically have the same opinion and who are just kind of choosing themselves to be participating. Okay. All right, let's go ahead. Oh, I just want to come back to this exam tip here. I try to put these in when we can. These are things that graders have said are sometimes problem areas when they are grading the test. If you are ever asked to describe how the design of a study could lead to bias, there are two things that you have to state. And what typically happens is usually someone only answers one of these two things, but not both. And to get full credit, they need you to address both. Okay, so I'm going to use these examples that we've discussed so that you can see how we would maybe address both of these things. You have to discuss what the problem is with the design, meaning what was the problem with the way that the people or subjects were selected, and then how does that problem lead to either an under or overestimation of what you're trying to survey. Okay, so for example, this school library situation, we could say the problem with only going to the school library is that that's not a true random sample. You might have a bunch of students in there who are either all studious and they go there to work on their homework, they care about doing their homework, or maybe they are working on a large project that is taking up a good chunk of time, and so that would result in an overestimation, okay, an overestimation of the true average time spent on homework if we were to have taken a true random sample of students just in the student body, okay? So it's linking together the problem with how the data is collected and then the way it was collected, that would either lead to an under or overestimation and kind of give a supporting reason why. Okay, so let's go ahead and look at this example here. They are wanting us for this to identify the sampling method that is used and then explain how the sampling method could lead to bias. Okay, and these are bad sampling methods. So our options are either going to be that a convenience sample was used or a voluntary response sample was used. Okay, so here it says a farmer brings a juice company several crates of oranges each week. A company inspector looks at the 10 oranges that are in the top of each crate before he decides whether to buy all of the oranges. Okay, so he's not actually going through and selecting 10 oranges at random from the entire crate, assigning them a number and then randomly generating 10 of them and pulling those out. He's just simply looking at the top, okay? So that's very convenient for him to do that. He's not digging down underneath. So this is certainly a convenience sample. Now, when it says here, we're supposed to explain how this could lead to bias. Remember back here on the front that in addition to addressing what the problem is, you have to say how that could lead to either an over or an underestimation of what you're trying to measure, okay? So we could say something like this, okay? This is not the only answer, but this is a good answer. We could say that this could lead to an overestimation of what we'll call good oranges if the farmer puts his best oranges on top, okay? So you don't just want to say, oh, that could lead to an overestimation of good oranges. There has to be a reason. Like, why would just looking at the top 10 oranges at the top of the crate lead to an overestimation? Well, it would lead to an overestimation if the farmer was putting his best oranges on top and maybe the ones that aren't quite so good towards the bottom of the crate. Okay, question number 2 says, the ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded, and 67% of them said no. Okay? So what's the issue with this? Well, the issue with this is clearly a voluntary response sample. Okay, people are volunteering to call in. Okay, we could say that this could lead to an overestimation. Okay, an overestimation of no responses. And the reason is because those who maybe are content with the headquarters. Oh, I already have this written here, don't I? Huh. Okay, I'm sorry. So I already have this written on here. That's nice. Okay, so maybe we should just title this. I probably wrote this because this was just so much to write here. Okay, I apologize. So we want to definitely call this a voluntary response sample. And then here's our problem with that. We would say this would result in an overestimation of the true proportion of people who would respond no, because those who feel strongly about wanting the headquarters moved, they are the ones who feel compelled to call in. Okay? The ones who are happy with where the headquarters already are located, they're probably not as compelled to call in. Okay? It's those who want to change are more inclined to phone in. Okay? So that's kind of why maybe these results, the 67% no, it could be overestimating those people because the yeses didn't really call in. Okay? All right, now let's talk about some errors that could occur in a survey. Okay? So the other two things we just discussed were bad ways to collect a sample, but now we're going to think about maybe just some errors that could happen in your surveys, okay? The first one is called undercoverage, okay? And just by the very name of this, you can think undercoverage is something that occurs when some groups in your population, they're just simply left out of the process of choosing the sample. So in other words, you want to kind of think, look, they never had an opportunity to be selected, okay? Now, what would that look like? Well, if we were going to survey, say, households, okay, so we were going to only contact, people who have homes, obviously, we would be missing anyone who was homeless, okay? They would not have had an opportunity to be selected for the survey. Maybe anyone who is a prison inmate and they don't have a household, they would be excluded from this particular sample, or maybe college students in dorms. They're not in a household possibly here. So this would be an example of undercoverage because people that fall into these categories were completely left out of the process. Okay, when you do things at random, and it does depend on what your population is, but if the population is all of the people in an area, then this would have some undercoverage because these are people possibly in the area that would never have had an opportunity to have been chosen. Okay, let's go ahead and look at the second error that could occur. This is called non-response. Okay, and non-response is when an individual who is actually chosen for the sample, so they're selected, but for some reason they can't be contacted or they're refusing to participate. So you could think of it like this. They had an opportunity because they were chosen, but they themselves are choosing not to actually participate in the survey. So you see this a lot with mail surveys, things that you get in the mail. The person might say, oh, I'm not going to complete that survey, and they simply throw it in the trash. Or maybe a phone survey where they're calling. You see this a lot around presidential election time where they're trying to gauge, how the candidates are doing. Possibly a person maybe hangs up. Okay, so they were selected because they got the mail survey sent to their house, or they were selected because the phone call made it to their place of residence. It also could mean that they just took the time to feel strongly about the issue as opposed to those who just kind of, take a pass on participating. So non-response. They were selected, but they're choosing not to participate. Okay, as opposed to voluntary response bias, which is generally comes up with the voluntary response sample. This occurs when your participation is actually optional. Okay, usually only people who are feeling strongly about it participate. And so you want to think, okay, look, the volunteers, they're differing in some meaningful, substantial way from those who are choosing not to volunteer. Okay, so often this is when there's web surveys, phone-in surveys, call-in surveys, things like that. People who choose to respond generally feel like, excuse me, that their responses, they want them to be heard. Maybe they feel strongly about a certain issue. Okay, and so this is when you tend to get your results to either over or underestimate a certain way because those who are choosing to respond kind of feel strongly about the issue per se. Okay, and then the last one, and this one's pretty easy, it's just the wording of the question. Sometimes the wording of the question can introduce, I guess there are 5 here, it can introduce bias into your results, okay, and it can influence the answers that people are giving. For example, if you say, since the cafeteria food has been known to be served too hot and burn students' mouths, do you think that the health inspector should come to investigate the conditions in the cafeteria? Okay, clearly the person who worded this question is using what we would call, whoops, I think I misspelled that here, persuasive writing, okay? So they are trying to influence the person. When you word questions, you want to be very generic about it so that you're not throwing in any adjectives that in any way would persuade the person, either knowingly or unknowingly. Here's another example. Some dog owners have been bitten by their dogs. Do you feel that there should be stronger regulations in place to help control the pet population of vicious animals? I'm just going to put some ditto marks here, meaning same reason here. This wording of this question is showing persuasive writing. And finally, does it seem possible or does it seem impossible to you that the Nazi extermination of the Jews never happened? Now, this question right here, that was too wordy. And when I say too wordy, like they're using like all these double negatives, and if someone said yes to this or no to this, we're not totally sure what their view is because of the way that we have this worded. So that is a very badly worded question. And then finally, response bias. Okay, this is when a person is not completely honest with their answers because they're feeling some type of pressure to give a response that maybe they feel is the right answer or the appropriate answer rather than just giving their own truthful response. Okay, so we're going to see if we can take a few examples here and see if we can fit these examples into one of these like bad errors that could happen in a survey. Okay, so let's go ahead and start with this top one here. Let's say our population is all Dover High School seniors, and I draw out a random sample who are in advisory, and I survey those students selected. Okay, so my overall population is the seniors, and so I go into the senior advisory classes, and I'm randomly choosing, maybe using a random number generator so it's properly random. Does anybody see any issues that could occur with me going into advisory? Okay, one issue could be students who are absent. They're seniors, but they would not have had a chance to be selected. Maybe it's a Kent student or a Buckeye Career Center student. And so these people that fall into these categories would actually not be included. Okay, so if they're not included, then this particular example would fall in under coverage, because these individuals could very well be seniors, Dover High School seniors, but not have had an opportunity to be selected. Okay, let's look at the next one. It says the population is now Dover High School staff. Let's say that I select a random sample of 4 staff members, and these are the 4 that I selected. Okay, I put everybody's name in a hat maybe and selected these 4. And then what I'm doing is I want to find these staff members after school, but it seems like I can never find Mr. Ift because he's always already left for the football field. Okay, so again, I selected it randomly, but it's like I cannot find Mr. Ift. Okay, so this would be an example of non-response bias. Okay, Mr. Ift was selected. Okay, he had the opportunity to be selected, but then I'm unable to locate him to get his response. Okay. All right, let's go to the next one here. It says the population is now the entire Dover High School student body. It says on the announcements to check your email to vote for homecoming queen or king. Okay, so if you go into your email, you can cast your ballot. Let's look at what we have here. Okay, so things we still have left are response bias, voluntary response bias, or the wording of a question. Okay, I think that when you go into your email and you vote, that is completely voluntary. Okay, so you are only getting responses from people who are caring about that particular issue. Okay, that would be voluntary response bias. Okay, and then the last one here, the population again will be Dover High School student body. Here it says Mrs. Grafe is randomly going to select 50 students from the student body. So this is good that she is randomly choosing them, okay? But it says here she gives them a 1-question survey asking them if they have ever cheated. Okay? Then they are to hand their survey back to her when they finished it. Okay? This is a prime example of response bias. Remember what response bias is. That is when they're maybe not completely honest because there's some pressure involved there. You could be really intimidating to say that you have cheated before, and then you're handing your answer back to the principal who could glance down and see what your response is there. Okay? Okay, we are going to just wrap this up here with one more page of the notes here, talking about how we gather data, okay, and it can be a variety of these ways, and we'll look at some of these here. Okay, here are different ways to gather the data, and this is what we want to focus on. You are going to need to make sure that you know these, and we'll be walking through these in the rest of the notes. A simple random sample is the only one that we're going to talk about here to wrap up this video, and then in the other videos we will discuss these other samples. Okay, but for today, a simple random sample known as an SRS here. Okay, the best way for you to avoid any bias is always making sure that you are gathering your samples randomly. Okay, so we're going to look at what this means to collect a simple random sample. Now, the first part of this is pretty logical. The second part sometimes is confusing for students. Okay, so this is saying it consists of gathering together n individuals from your population. So let's say you wanted a sample of maybe 10 people from the student body, okay? Okay, 2 conditions have to be met for it to be a simple random sample. One is every individual that's in your population has to have had an equal chance of being selected. So this could be done by taking everyone's names, putting them all into a hat, mixing them up, drawing one out at a time, mixing in between. That means that every single individual would have had an equal chance of being selected. Okay. The other part to this that can be a little confusing is that every set of 10 individuals has to have an equal chance of being selected. Now, I'm going to discuss what that means because that can be a little tricky to interpret what is meant by that. Okay. Here are some methods of gathering a simple random sample. The easiest is, I mean, this isn't always the easiest, but on your problems in AP Stats, when it asks you, how are you going to randomly gather your sample, sometimes the easiest way to explain is just to say, I'm going to place everyone's name in a hat, and then I will randomly draw out, n number of names from the hat. Other options is to assign each person in the group a number, and then use either a computer, which we usually don't do much, a table of random digits, which we'll talk about tomorrow, or say you're going to use a random number generator on your calculator to generate 10 numbers from 1 to 100, and you've assigned every person a number 1 to 100. Okay. All right, so let's take a look at this example here at the bottom, and this is where we will close for the day. Let's say that I wanted to draw a sample of 4 people from this class, okay? And I'm just going to use the hat method. So I'm going to put all of your names on an equal-sized piece of paper or maybe an index card. I will then fold that, put that into a hat or a basket. I'm going to randomly choose out 4 names. Let's just say that the names that I draw out are Eddie, Emerson, Cassidy, and Carter. Okay, you were randomly chosen. That is a simple random sample because every single individual had an equal chance of being selected, and every set of 4 individuals from the class had an equal chance of being selected. And so what I mean by that is every possible combination of any 4 of you in the class could have been put together for my sample. Now, where you see the second piece here being a little bit more relevant is I'm going to jump over here to where it says sample 3. Let's say now I want to draw a sample of 4 individuals, but I'm going to put some restrictions, some parameters on this. I now want to make sure that my sample of 4 includes 2 girls and 2 boys. Okay? If I'm going to do that, I'm no longer going to put all of your names in one hat. Instead, I'm going to separate this into 2 hats where all of the girls' names are in one hat and all of the boys' names are in another hat. Okay, so let's say that I do that, and let's say that the 2 girls' names that I choose are Hannah P and Hannah G. Okay, so I randomly selected you from just the girls, and let's say that the 2 boys are Blake, and let's just say that Carter got chosen again, okay, for this separate sample here. Okay, now the question is this actually a simple random sample? Well, it has to meet both these criteria to be a simple random sample, okay? 1, did every single individual have an equal chance of being selected? Yes, you did, because all the girls were, even though they were in separate hats, you all were in a hat. You all had an opportunity, an equal opportunity to be chosen. So it meets that criteria. Here's the criteria that this doesn't meet. Every set of 4 individuals did not have an equal chance of being put together, okay? Kind of like every combination, okay, we got to think that every combination had an equal chance. So for example, I could not have had, as my result of 4 people, I could not have had Blake, Carter, Eddie, and let's say Peter, okay? You 4 boys could not have been the 4 people in my final sample because this was restricting me at having 2 girls and just 2 boys, okay? So for that reason, this, and I'm going to make a note here, this is not an SRS, short for simple random sample. Now, does it mean that this was a bad way to gather the sample? No. This is probably what we did right here is something that's going to fall into one of these other sampling techniques, which we'll talk about in the next video. But this is not a simple random sample because my final result of 4 people couldn't have been any combination of any 4 individuals in the whole population, which is our class. Okay, that is where we're going to stop for the day. These are a few problems that you could try that would go with these notes here.